Hello class. So this is a good review problem here. Let me just point out some of this stuff here. Exam 2 is going to be Monday, October 19th. And try exam 2 review at that website, math.unm.edu/tilde Kevin B. And this test is going to cover these sections 3.5, 3.6, 3.7, 4.1 through 4.5. And remember, if asked on the test for a max or min value, give the y coordinates of the vertex only. Okay, so let's do section 4.5. So it's a long word problem. The demand for a certain model smartphone is given by P, which stands for price, equals 400 minus 0.0 what x, where P denotes the unit price in dollars and the variable x denotes the monthly quantity demanded. How many phones should be produced in order to maximize the revenue, according to this price equation, this demand equation? So when you see the words maximize or minimize, think derivative. And then you also think you want to set that first derivative equal to 0. That will tell you where the horizontal tangent line is, which implies a peak or valley. In this case, a peak, since it's going to be a maximum. And then also, what price should be charged in order to maximize the revenue. So we can figure that out too. We want to find the optimum price that should be charged for each phone to maximize the revenue. So let's do the solution. Sure. Okay, so my brother's holding the phone now. I just rewrote the price equation right here, and we got to know this formula. Revenue equals X times P. X is the number, the quantity sold, and P is the price per item sold. Okay, so revenue is just going to equal this thing times X. So I have that. Let's use the distributive property, and we have that. Notice this is a quadratic, which implies we will get all parabolas have a vertex. And I can write this as, in more fancy function notation, R of X equals, and I just switched the terms around so it's in standard form. Notice this parabola opens downward because A is negative. A, remember, is the coefficient of the x squared term. Okay, so that implies the vertex is a maximum, which is an upside down parabola, and isn't that vertex the highest point on the parabola? Sure. Okay, let's find the derivative of this revenue function, because we were asked to maximize the revenue. So let's find the first derivative of the revenue function. And by the power rule, term by term, we get this. And then we want to find the critical numbers. So let's set the first derivative equal to 0. So we have that. And then solve that for x. I added 0.02x to both sides to give me this. Then divide both sides by 0.02, and we get that, and that simplifies to 20,000. So, how many phones should be sold to maximize the revenue? 20,000. Notice the x-coordinate of the vertex gives you the ancillary information. Okay, so selling 20,000 phones will maximize the revenue. Let's answer the second question now. Plug in 20,000 for x in the price equation, and that will tell us the optimal price. So there is the price equation. And what are we going to let x equal, which stands for the number of phones sold? How about 20,000, because that's apparently the optimal number to sell. So what is P of 20,000 going to equal? 400 minus 0.01 times 20,000, and that equals 200. So sell each phone for $200 and you will get the maximum revenue.
And you're allowed to use calculators for the test, so just do that in a calculator and you'll get 200.
Let's see, are we told what the maximum revenue is? This is the number you should sell to get the maximum revenue, right?
Right.
So what is the maximum revenue? Was that ever asked?
No, the question was how many phones should be produced in order to maximize the revenue. So they didn't actually ask for the maximum revenue. They
I
just
suppose that would be, X would be 20,000 times P,
yeah, right here.
which is 200.
Yeah, if you go to your revenue function, this is the easiest one to go through. So if they did ask you for the maximum revenue, just plug 20,000 for all the X's, and that would be the maximum revenue. But don't answer questions that are not asked. In this case, they just want to know how many phones would produce the maximum revenue, but they didn't ask for the maximum revenue.
And then one more thing I want to say about we noticed this was a maximum because the parabola opens downward since A was negative, but you could also figure out if this is going to be a maximum or minimum by taking the second derivative of the revenue function and then plug in for X the critical number,
20,000.
because that's going to be in the middle of the concave up or concave down. So if I guarantee if you do R double prime of 20,000, you would get a negative answer since this is a maximum.
Okay. Good night, everyone.